Okay, we're going to pick back up on lesson 11. So get yourself to 11.3 activity. So what we've got to do in this activity is we have a graph, we have our line, and we've got two of these slope triangles from the line. A little bit of review. When we have our line here, okay, so this is our main line right there. We can create similar triangles, and the long side of each triangle is actually on this line. And if that happens, I can actually create an expression that describes the slope of my line or the steepness of my line from the triangle. Okay, so number 1 says, complete each diagram so the vertical and horizontal segments have expressions. Number 2, use what you know about similar triangles to find an equation. So we'll get to each of those things. I'm going to zoom in a little bit on this picture just so that it's a little bit easier for you to see what we do. So number 1 wants us to write expressions for each of these triangles, the vertical distance over the horizontal distance. And on our triangle ABC here, it's actually very simple because they give us the vertical distance over horizontal. They give us that information. Our vertical distance is 3. Our horizontal distance is 4. Now our second triangle, DEF, is where it gets a little tricky. I can't tell exactly how high this side is. I can't tell exactly how long side the horizontal side is. And we can't estimate, and we're not going to use a ruler. We've got to use the information given to us to determine the expression for the vertical distance over the horizontal distance. Okay, so we've got to use the information that's given to us. Now, one thing to note is we do have a couple ordered pairs. I know that D is at 0, 1. And I know that E is at X, Y. So I know the ordered pairs. Okay. Now I've just got to find the distance of each of these sides. Clear this out. Okay. So if I look at my ordered pair for E, it's telling me that to get to this point from the origin, I had to go over X units, up Y units. That's how ordered pairs work, right? You go over the X coordinate amount of units, up the Y coordinate amount of units. So for it to tell me that my ordered pair is XY, that means my horizontal distance was X and my vertical distance was Y. Okay, remember that. So what that means is if you think about my triangle here, the horizontal distance from the origin was X, and it actually gets me right here. Do you see how that distance would be the same? So my horizontal distance is actually X. Now I would have to travel up Y units to get from this point down here all the way up to the top. The only thing is I don't want this entire distance up. I only want this distance here. So I don't want this entire y distance. And again, the reason that that distance is y, I'm getting that from this coordinate. The coordinate being called y means that from the x-axis, I had to go up y units. But if we look here, how many units is this extra piece? It's 1. So what I actually have here is I have this whole piece is y units, but I don't want this little hunk right here. So I have to take away 1. If I take away this 1, that's how I get my distance of this side. It's y minus 1. Okay, so again, to figure out my horizontal distance, I just used this point to help me. I had to travel over x coordinates, up y, or not units, not coordinates, units. I had to travel to the right x units, and I had to go up y units. Well, these are the same exact distance here, so this value is x. My horizontal distance is x. Now I don't want this whole distance. This whole distance is y. I don't want the whole distance. I only want this piece right here. So if the whole distance is y, I'm going to remove this 1 unit. That's where I get y minus 1. Okay, and if that still doesn't make sense, we're going to do this a couple more times. So if we look at how I made my ratio over here, it was vertical distance over horizontal distance. So if I look at this triangle, it's the vertical distance over the horizontal distance. So this is the expression for my first triangle, and this would be the expression for my second triangle. That's the answer to number 1. Let's go back here for a second. 2 says, use what you know about similar triangles to find an equation for the quotient of the vertical and the horizontal lengths. Here's all that's saying. Remember that when I create these similar triangles, the ratios of the vertical over the horizontal should be equal. Okay, for example, if I were to create a triangle, let me clear some of this out. Let's say I were to create this triangle. Pretend that this is an actual straight triangle. Remember, if I can create a triangle where the longest side is along this line here, then I know that they're similar. If they're similar, the ratios of the vertical distance over the horizontal distance would be equal. Remember that. My vertical distance is 6. My horizontal distance is 8. Do you see how those fractions are equal, equivalent? So we're going to use that information to help us with number 2. So number 2 says, create an expression that shows these 2 triangles have equal ratios. Well, my first triangle is 3/4 equals my ratio for my other triangle. Y minus 1 over x. That's all they wanted us to do in number 2. Now take a look at the second example. Same type of situation. Complete each diagram so the vertical and horizontal segments have expressions. So let's look at our triangle ABC here. Same type of triangle. Vertical is 3, horizontal distance is 4. Let's look at our smaller triangle. Horizontal distance, cannot tell. It doesn't line up perfectly, and neither does the vertical. So we're going to have to use what we can figure out. Use the information we're given to figure out what we don't know. Let's look at each of these ordered pairs here. D is at 2, 4. So that means from the origin, I had to go to the right 2 and up 4 to get to this point, right? So that means for E, I had to go over X, I had to go over X units and I had to go up Y units to get to this point. So I'm going to use that information to help me find my horizontal distance and my vertical distance. So my horizontal distance is going to be this X distance, but without this part. Okay, so again, the distance from D to F is going to be X minus these units. How many units is that? 2. So I want to take this X distance and I'm going to take out 2. Hold on, let me show this a little bit better. Okay. So again, I'm going to go X units minus these 2 that I do not want. I don't want those 2 units because I want to start right here. So this distance is X minus 2. Okay. So now for this distance right here, I'm going to take Y units. So from the X axis all the way up is Y units, right? But I'm going to take out this chunk right here. How many units am I erasing? I'm erasing 1, 2, 3, 4 units. So this distance is going to be Y minus the 4 units that I just erased. Okay. So my vertical distance is Y minus 4. My horizontal is X minus 2. Now to create an equation, take one of my expressions and set it equal to the other slope triangle expression, the vertical distance over horizontal distance. And there is your equation. Now there's more you could do. We can manipulate this equation more to come up with something a little less messy. Um, if you want to try that, you can. If you want to try to simplify and change it around a little bit, you could, but this is completely acceptable. And that's it. Next up is the practice.